Hello everyone, my name is Victoria and this is Introduction to Competitive Programming. So I'm a former ICPC contestant for BME and I'm currently a PhD student at SID department. I'm researching algorithms and quantum computing. We organized this competitive programming student club for the university. And this semester, with 3 of our members, Ákos, Clevis and Levi, we decided to put together a video series on how to get started with competitive programming. So what is competitive programming? Actually, this picture was taken during last year and the regionals of ICPC. You can see one of our teams in the corner in the back. So competitive programming is a form of sport for anyone who likes coding and math. Contestants are either individually competing or competing in teams, and they have to solve puzzles or algorithmic challenges and then write code with their solution to submit them to a judging system. This is what the judging system will produce. So when you submit your code to the system, it will evaluate it against a lot of hidden test cases, kind of like unit testing, and then check if your answer was correct, and also check that you were within the time and memory limits of the specific problem. And these limits are very strict, so they are set in a way that you have to use a non-naive algorithm, something that you have learned either from math, like number theory, graph theory, or algorithms. And once you have passed all of those requirements, you will get an accepted solution and it will appear on the scoreboard like this. And you will be ranked among the other teams based on how many exercises you have done and how fast you have submitted each of your solutions. So there is actually a lot of pressure to do each exercise very fast. And this type of competition will definitely make you a better programmer to work under stress, learn how to write bug-free code, simplify your thought process, debug your code incredibly fast. Even if you are doing other types of development like web development, which I did in the past, it definitely made a difference that I did this formally. When you are working with a team, like in ICPC, you will also learn how to read other people's code faster. And if you look back, you only have exactly one keyboard, but 3 people. So you will definitely learn how to manage conflicts between yourselves. This is again from personal experience. So in middle school, in Hungary at least, you can do a lot of competitions. One of them is Nemesti Hamér that I formally participated in, OKTV, second category, and there are also international ones like the Olympiad and the Central European version of that. So if you've done any of these, then this is probably gonna be too easy for you. So we are aiming this for people who are actually just starting out. If you already have this background, then you should probably join the advanced sessions instead. Graduating from middle school, in university, the most important contest you will have is the ICPC. And there are others like Sapientia, and there are also online platforms such as Codeforces, Topcoder, LeetCode, and there are many, many other more where you can compete like up to 3 times a week, for example, on Codeforces, and do even more of these exercises against basically anyone in the world. So I want to showcase how an exercise looks like on Codeforces, and I chose this La La Land and Apple Tree. So this is the website. And immediately you can see one of the most important things about competitive programming, which is the time and memory limits. These are gonna be very strict. So for harder exercises, you might be processing up to like billions of numbers, maybe not billions, but millions of numbers under a second to get your accepted answer. And also there is a memory limit. Usually the time limit is the more problematic one. So we have a test description. Here goes. Emma lives in La La Land. La La Land is a very beautiful country. It's located on a coordinate. It's famous for its apple trees growing everywhere, and it has exactly an apple trees. So the ith one is located in position xi, and it has exactly ai apples. These are numbers that are coming on the input. So later on you will see examples of such inputs for this exercise. So Yammer wants to collect apples from the apple trees. He is currently standing on the coordinate 0, and at the beginning he can choose if he goes left or right, and then he will continue in this direction until he meets an apple tree that he has not met before. He takes all the apples from the apple tree and then reverses. And this process stops when he no longer encounters any apple trees in that direction that still have apples on them. What is the maximum number of apples he can collect? Then we have another section about the input format. This is also very important, especially for other exercises, because this will tell you the limits on the variables in the problem, which will determine the complexity required. So the type of algorithm that you need to come up with will heavily depend on these numbers. Do not skip reading this. So here we have at most 100 apple trees, and then the coordinates are within 10 to the power of 5 in positive and negative directions. The apple trees do not grow in the origin, so at the starting point you don't have anything, and you can have at most 10 to the power of 5. So this fits well within the integer limit, any programming language. And the output is gonna be the maximum number of apples AMR can collect. So let's talk about this problem, how I would solve this if this was a competition. I usually you can either use paper. I like my tablets. It's convenient because I can. So maybe the first idea that would come to mind for someone solving this problem is to just simulate it. So what's happening? We have a coordinate system, x-axis. We are standing in the origin, and we have, depending on the input, some apple trees. I'm just gonna draw an example. Maybe apple trees are there, and make them more tree-like. And then the input will tell me how many apples are on each. These are the counts. And what I want to do is make a choice. So I can either go left or I can go right. What happens if I go left? So I'm gonna first to this apple tree and pick that one up, then reverse direction, apple tree, pick those up, reverse direction again, go to this. And when I'm reversing direction here, I'm not gonna encounter anything, so this is where the algorithm. And I have been able to collect, if I go in the other direction, different result, going in the other direction, I start here, pick those up here, pick these up, and now I can the very last apple 2, outside of the screen, but we are okay. So I can reach the last one too, so that means I got 12 apples, right? Hopefully. So going right would be the better option, and we just output 12 for this input. You can imagine simulating this process basically in a for loop, just doing exactly what the task says, iterating on the input array, maybe sorting it first by coordinates, and then trying out both directions, maximizing the output. When I first started competitive programming, it probably was a similar, so like back in when I started, I probably would have come up with a similar solution for. But then I learned that sometimes you have to think a bit more about problems and then maybe come up with a better and simpler algorithm, which is easier to implement. So make observations and understand the problem. So you might have noticed already that when you are going from left to right to left to right to left to right, you can always kind of pick the same amount of apple trees on both sides. And if you are lucky, then you could pick one more at the finishing, at the very last step. So if I just have a bunch of here, but maybe very little trees on the other side, very few on the others. If I do the steps like this, then I will end up actually doing one more on the right than on the left. And if I choose unlucky, pick sides, I start here and do this motion, then when I reverse my direction, I will not have any apple trees. So if I choose the correct direction, I can get one more on this side. So we can immediately say, okay, let's count the negative coordinates. So let's say maybe those are legs or something, like a variable, and pause, same thing for positive coordinates. And then you can say that on one side of the origin you can pick all of them, and on the other side pick one more. So you can immediately see that these two will be out of the question. And if it's oriented in a different way, then it's gonna look like this, where the positives, you have fewer positives, and then on the negative side you can pick one more, and then these will be left out from the process. And you can kind of calculate, so based on just the count of the positive and negative coordinate apple trees, which side you want to go to, or which will be the starting and ending index of the range that you can pick down. And I actually implemented this. Let me show you the actual my submissions. Yeah, the one where I can check my submissions is called my submissions. And so I submitted this. So it was like almost good, but not entirely. So what I did, I just initialized counters, read in the input, counted how many of them are negative, positive, sorted the array so like they would be actually in the order because the input can be randomly like mixed up. And then I do this super complex equation to calculate the beginning and the end of the range that I can pick up, and then finally iterate on them and return the result. So it's this part, I mean, it wasn't that difficult to come up with it, but under like time limits and pressure and my teammates telling me I'm wrong or I should be doing it in a different way, which they would probably tell me, this would be very hard to calculate. And clearly I've made a mistake because it says that it's a wrong answer on test 1, and the reason why is because these S and E could be out of bounds for the array. And the quick and dirty solution for that was to just add a little extra in here. So I'm gonna say, okay, if S is next, I wasn't like thinking what was exactly the problem. I just wanted an accepted solution, which is what you want when you are doing this under time restrictions. So I just wanted to make sure that the range, if it's outside of the bounds, then it put it back into the bounds. Smallest index is 0, biggest index is n-1. So putting this max and min ensures that I'm actually summing up correct answers, and indeed this fixed my very complicated and hard to read like interval bound basically. So I got an accepted verdict. Then I woke up today and I realized that actually I'm overcomplicating as usual. This is something I'm still learning how to not do. And why don't I just make it simpler for myself and read in the positive and negative coordinates into 2 different vectors here. So I just made separate vectors and sort them like both. So I'm going back to the drawing board. What I'm doing now is not having a single array split in the middle at the 0th coordinate, kind of juggling multiple like bounds, but instead I just have an array in this order, the pos, and then another array in the opposite order. So the negative coordinates are decreasing, the positive coordinates are. Because this way, it's so much easier to tell which part of the arrays I need to sum up. Because in both arrays, it's going to be at the beginning. So it's going to be starting the 0th index here and here as well. And in one case, it's going to be the entire array. In another case, it's going to be like one more than the size of the other array. And I would call this third option, which is make your life easier. I'm just going to write it there. I think I'm learning this a lot more in this year because I've started actively doing a lot of Codeforces contests and actually participating in many of them, and it's night and day. So I think I'm a lot better now than I was. So back to the code. After I did that, I'm just gonna for loop, size of the smaller array plus 1, and I'm just gonna check that I'm not over-indexing the actually smaller array at this very last element and just add them up. And bam, I have a solution. But the difference between this solution and the other one, which was, well, originally it was this, is that this is very error prone. Even though I have already done some amount of thinking, this is just complicated, and we don't like think about too complicated things if we can make them easier and less error prone just by like looking at the same problem in a different angle, maybe using different data structures that just admit to a nicer. Actually, the reason why I picked this problem to show you at the beginning is because this was the very first problem that I have done ever on the Codeforces site. So I just scrolled back all the way to the beginning and looked at my first submission. And boy, what did I see? Where is it? Yeah, so 2015, 9 years ago, I was 20 years old. In my 3rd year of my bachelor studies, second time competing in ICPC. So during that summer, like before my second time in ICC, and look at my code. I like, okay, I defined the structure again. Why did I do a type def? I don't know. I don't need that. Okay, I put the origin also as part of the array. Not in the input. I'm putting in comments because I was a very organized programmer back in the day. So they teach you to put comments in the code when you are developing for a software company. That's also debatable. Like some people say you should comment your code. A lot of people with clean code say you shouldn't. But for competitive programming, you are holding up very different practice. So this code does not need to be clean, and it does not need to be maintained past the 5 hours the competition takes. So you need to write something fast, but still error. So there are some different rules. You don't need to comment your code this much. Maybe if you're doing something weird, I don't think this random, completely empty for loop. I don't know. I don't even know what I was doing. Then we do a binaries because we know how to do that. And it's so cool that we can do that. So I could linear search even because n was like 100. But we are doing binary search because we are cool and we know how to, for all the wrong reasons. But let's go. And we find where the 0 is. So after sorting it into the array, we find where the 0. You have already seen the code, so you know this is like, what are you doing, Vicky? Well, anyway. And then we do some even more hacks, because this is some more math that I didn't want to like fully understand, but basically like 2 times the position of the origin. So that's going to be like sometimes larger than the total size of the array, sometimes smaller. And I probably did some math on that, and then based on that I calculated the range again, and then we did an accumulate. So the accumulate function is very nice. It can sum up ranges. Unfortunately, because this is a struct, I needed to implement the sum function on it. Oh, sorry, like the function that takes the accumulator in one parameter and the like struct on the other. So it would be able to sum it up. Could just run a for loop on, who cares? But I know accumulate, so I'm gonna use it. And then print out. So this was 10 years ago. I think I've improved a lot since then, and I'm still probably have a lot of work to do. But I think it was really fun to look at my own code and see who I was. Yeah, so this was, I wanted to show one more thing, because I prepared for it. So this is the submission page on Codeforces. So we will be giving you similar links like this one, and you can submit code here. So you can just pick the problem. I don't understand why it doesn't pick it automatically, but you have to pick the problem again. So this was a contest. This was the problem A from it, selected from the drop down. And at least we will be using C++ in our videos. Like if you want to use a different language, that's fine, but we very much do recommend learning C++, because for the harder problems, it's going to be much more convenient. We don't really use Java. We sometimes use Python, but C++ is all you need actually. And the 20th version is the current standard on ICPC, so use that because then you will learn exactly the language features that are available to you on ICPC. And then you can either submit by copy-pasting into this text box, or you can pick, and I'm going to demonstrate how to do the file browser version, because Clevis was very adamant that people have to know that there is a browser version. So I have somewhere in my amount of repositories code, which is the simpler.cpp. I picked it and I can just submit it. And I don't know if this is gonna be compiler error. Oh, okay. So it's probably an accepted answer. I forgot what I left. This is the submission process. And other than accepted, you can also get verdicts like compilation error. So if your code does not compile at all, then you will get this. If there is some error, just like like division by 0, or Stack Overflow, if you done an infinite recursion or something like that, then you get a runtime error. If your program exceeds the allotted time, it will get cancelled, stopped, and then it will tell you that there was a time limit exceeded on one of the tests. And there is also the memory limit exceeded. If you used too much memory, if you allocated too many data structures, then you can get this as well. And these are not accepted answers. You have to stay within the limits, run correctly, and and the wrong answer. So if you didn't submit correctly, then we get a wrong answer. So for this submission, I also wanted to mention a bit that when you're out of contest, you're just practicing, the submission system will tell you, well, at least like partially. At this point, there's even diagnostics implemented, so it's actually telling me that I did a array out of bounds error, and that's why I'm get this wrong answer. So it will tell you the hidden inputs as long as they are not too large, and what your code responded, what the actual answer is supposed to be. That's the jury's answer. It tells you why it's wrong, and you can look at this. I think if you are like just beginning, maybe it's easier to look at it, but as you get into competitive programming, I recommend trying to solve the problem without looking at these comments, because it will not be available to you during a real life contest. So not on ICPC, and also not on Codeforces contest either. And it's better to get used to that uncertainty, because that's how we prepare for the actual competition. Okay, I think this is all I wanted to say about Codeforces, so let's move on to the next slide. So VProg is short for versenyprogramozás, and we love algorithmic challenges. We solve ICPC problems, especially on the advanced sessions. We also spam Codeforces contests. Like during the summer, we did a lot of these contests, and I think it helped a lot to the people who participated. But this is not all that we do. We started doing open challenges. So there was this thing called the San Vitale challenge, which I'm going to show you. So this is a basilica in Italy, and their like beautiful painted windows were broken in fragments like many years ago, and they recently uncovered this, and they are trying to reconstruct the original windows by hand currently, so meticulously piecing together every single fragment based on the outline, and also like the colors. Like you can see here that these are painted glasses, and the color also tells you a bit about how they should be put together, because for example on this one you can kind of see these concentric circles, and then that's also, at least for the human observer, that's pretty clear that this works like this. But it's not so clear for the computer. Unfortunately, the humans are very inefficient at doing puzzles at this scale, so they are looking for computer help, and they proposed a challenge, and we participated in this challenge together with 5 people from the VProg advanced sessions, and they actually coded it down, so it was actually mostly their invention. It's not that much of a complicated algorithm, but I think it's pretty cool that they did it. And we ended up actually, like, I feel like we did pretty well, and we ended up as co-authors on the paper for this conference. So this is a European conference on computer vision, and one of the workshops is on artificial intelligence on digital humanities, and we have a paper with 5 bachelor students in this right now. So it's very cool. We want to keep doing these challenges as well. The next planned one is probably the PACE challenge. It comes out around November. It's also a pretty fun competition for parameterized algorithms. We also have topics for doing TDK and thesis research. So if you get into algorithms and do competitive programming regularly, there will be other stuff that you can do as well, if you're interested. We had 2 external speakers in the past semester. One of them is my colleague at the department, Péter Szeredi, who is like one of the top people in Prolog, and he gave us a mini lecture series on how to use Prolog for algorithmical problems, and how this can be also used for challenges like the ones I mentioned. It was very educational, and I believe he would be very happy to work with very good students who are in this competitive programming field. And we had another one from Daniel Varga, who is from Rényi. He explained to us how methods in competitive programming can be actually very similar or used for pure mathematics research, which is one of the areas they are currently exploring. One of our members is doing his bachelor's thesis in this with Dani in this semester, so I'm pretty excited for how that will. So these are like external speakers, which are very cool. We also have the quantum algorithms that I'm doing right now, and I have some interesting questions that you could possibly help me with. I'm currently doing a quadratic optimization on the adiabatic quantum computer. If you are interested, hit me up. And one of the questions I've had a few people look at already is minor embedding for these types of problems. So how you can transform the problem into a form that is runnable on a computer. Like it involves again some algorithmic considerations. Okay, so the plans for this video series. So we're aiming at software engineers at BME, second year, because at that point you have done your C++ course and also ITC or BS for the Hungarians, 1 and 2, and also theory of algorithms. So you should have all the basics that you need. We are looking to help people who are beginners in competitive programming to get into it, get started with it, and then hopefully join the advanced sessions. There will be 11 weeks, one topic every week. This is the first one. And video will be coming out every Friday, focusing on the parts how to solve an actual problem where the ideas or where the solution is much more concealed than what it was, for example, on the midterms of theory of algorithms. So you will have to think and uncover each and every problems, and also how to actually implement them in C++. So how to code those algorithms that you have learned in theory. There will be 3 to 4 homework tasks for each week, and you can discuss and submit these on our Discord. We will be very happy to have you there, so please join it. I will show the link soon. And the solutions will be posted like next week with some explanation on how to do each of these tasks. You can see the current topics, so this is not an extensive list. This is just some topics that we felt like would be very good for beginner levels to get into it, and then you can further your studies in the advanced. Starting out very strong, we have homework immediately for the first week. So this is none of these are algorithmic at all. This is just for you to dust your programming skills off, especially like homework 1 and 2, so present from lane and chat room. The task tells you what to do and you just implement it. Homework 3, so we were both children, like needs a little bit of consideration to pass the time limit, but not too much. So once you get that idea, it will let you pass the limits and get an accepted. And we also have a challenge. So this is we believe it's a harder problem. It does not involve anything algorithmic. So the solution will be fully done on paper. So you have to come up with a system using math, basically, that will work for this task. And the implementation is then pretty easy. So after you know what to do, coding it is not going to be hard. You can submit these via Discord. So we have test boards. I will show in a second. And collaboration is encouraged. So this is not a university course where we are like making homework or something. You are not being graded. So you should be collaborating with one another and talking to each other about the solutions and asking for help. So we will also be there in the test board. You can use spoiler tags. So Discord has this feature to hide what you wrote, and on a click it will uncover it where it makes sense. So don't like spoil the entire solution on like the first day. Let other people also discover it for themselves, but use it like with common sense, basically. So I'm going to show the Discord. So as you can see, we are very supportive. In the general, you can like chat about anything, like off-topic stuff even. And when you are done with one of the exercises, you can come here into the test board, and you can already see that I've posted like topics for the first week or the exercises. And if you come here and if you solved one of the exercises and you made a submission, please post the submission link here so we can all like celebrate that you've done it and also like look at each other's code. I also really like reading other people's code and learning from them, because sometimes they use stuff in C++ I wasn't familiar with, or they make a much simpler solution to something I overcomplicated possibly. So it's very nice to be able to read each other's code, and that's how we usually like share these. And I will also be posting the videos in. Okay. And this is the link. So join us now, and see you in the next video.